Okay, so this is Math 105, Section 1.5, Part B. So we finished last part by completing the square in quadratics. Now we're going to look at a technique where you can do this kind of generally for any quadratic. So what we can do is if we took any quadratic, ax squared plus bx plus c equals 0, and completed the square on that, we could get what we call the quadratic formula. And that's kind of a general way to do it using a formula, so we don't have to complete the square every time. Okay? So when you have this form, this is what you get for your solutions or your roots. X equals minus b plus or minus the square root of b squared minus 4ac over 2a. Okay? Where this is your a is the x squared coefficient, your b is the x coefficient, and the c is the number part that goes with that. Okay, so x equals minus b plus or minus square root of b squared minus 4ac over 2a. An easy way to do this calculation is to do the square root first. Do that. We call that the discriminant inside the square root. So b squared minus 4ac. Do that first, then take the square root, then do your minus b plus or minus that divided by 2a. Makes it a little bit easier to deal with. Okay, so let's look at this first example. 3x squared minus 5x minus 1 equals 0. We can't factor this. Okay, so we're going to use a quadratic equation. Here our a is 3, our b is minus 5, and our c is minus 1. So we identify our a, b, and c, and then we plug it into our quadratic formula. So minus b would be minus a minus 5, since b is minus 5. B squared minus 5 squared minus 4 times a times c, so a is 3, c is minus 1. So we have 25. Now this is a minus, so it's actually 25 plus 12. Okay, so that's how we get the 37. Minus a minus 5 is a plus 5, and then 2 times 3 is 6. So these are our two solutions, plus 5, plus or minus square root of 37 over 6. Okay. If we want to get approximations, we can use a calculator. We wouldn't do these by hand because of the square root of 37. So 5 plus the square root of 37 over 6 is approximately 1.8471, and 5 minus the square root of 37 over 6 is approximately minus 0.1805. Notice these are one's positive, one's negative. That's very often the case. Okay, for our next example, we're trying to solve this equation. 4x squared plus 12x plus 9 equals 0. This is something that generally, actually you can factor this, but let's not worry about that. Let's use the quadratic formula. Okay, so x equals minus b, so minus 12, plus or minus the square root of b squared, so 12 squared, minus 4 times a is 4, times c, which is 9. Okay, so b squared minus 4ac. This is 144 minus 4 times 4 is 16, times 9 is 144. So these actually cancel out. So notice we have a square root of 0 here, okay? And we're going to get minus 12 plus or minus 0 over 8, which is minus 3/2. So notice here we only get one solution because we actually got 0 inside that square root. Now that will tell you generally, either if your square root is 0 or if it's a perfect square, that you could have factored this, okay? So we actually could have factored it to get this solution, but you can use the quadratic formula as well. So we just have one solution here, x equals minus 3/2. Okay, our third example, we have x squared plus 2x plus 2 equals 0. This is something we can't factor. So we'll use quadratic formula, and our a is 1, okay. Our b is 2, and our c is 2. So those are our three constants. Okay, so x equals minus b, so minus 2, plus or minus the square root of b squared, 2 squared, minus 4 times a times c. So a is 1, c is 2, so minus 4 times 1 times 2. So we have minus 2 plus or minus the square root of 4 minus 8, which is square root of minus 4 over 2. Now this is a red flag here. Okay, so if you have a negative square root, it's not a real solution. Okay. Now we can factor out a 4 out of that, and that would give us 2 times the square root of minus 1. But either way, we get a negative square root. Okay. Now what does that mean? That means this has no real solutions. Okay. There is no root to this. There's no real solution to this. Okay. So we end up with minus 1 plus or minus the square root of minus 1. No solution there. Okay. We could say no real solutions. Okay, since the square of any real number is non-negative. We can't have square root of -1 in the real numbers. It's undefined in the real number system, so the equation has no real solution. Okay, and that gets us to the topic of what is our discriminant. Discriminant of this quadratic, ax squared plus bx plus c equals 0, is, sometimes we use capital D, but it's b squared minus 4ac. So that's what's inside the square root. Okay, think when you're doing the quadratic formula, is a discriminant. Okay, do that first because that tells you what your solutions look like. If you have a positive in the square root, okay, then you have two distinct real solutions to your quadratic. Okay. If you have a negative, like we just did in the last example, then it has no real solution. Okay. And then if it's equal to 0 in the square root, then it has exactly one real solution. So that was the previous example, okay, the one before the last one. Okay. So we have three scenarios here. Positive discriminant, b squared minus 4ac, the thing in the square root is positive, means we have two real solutions. A negative means there's no solutions because you can't take the square root of a negative. And then if you have a 0 in the square root, then it just goes away, right? And your solution is just minus b over 2a. Okay, so here's some examples where we're just going to look at the discriminant to see how many real solutions we have. So we're actually going to solve this. But okay, so for a, x squared plus 4x minus 1, our a is 1, our b is 4, and our c is minus 1. So we're just going to look at that b squared minus 4ac, which is 4 squared minus 4 times 1 times minus 1. So that's 16 plus 4, which is 20. That's positive. So we can say that this thing has two distinct real solutions because our discriminant is 20. Okay. For b, 4x squared minus 12x plus 9. Our a is 4, our b is minus 12, and our c is 9. So we have b squared, we have minus 12 squared, minus 4 times a times c. So this gives us 144 minus 144, and that was actually the example we looked at before, right? But it was, I think we had a plus 12 or whatever it was. But in this case, we still get 0 in the square root, which means we have exactly one real solution. Okay, our last example, we have 1/3 x squared minus 2x plus 4 equals 0. You kind of have coefficients that aren't necessarily integers. They could be rational numbers. They could even be irrational numbers. So remember, your coefficients can be any real numbers. Okay, so here our a is 1/3, our b is minus 2, and our c is 4. So we have b squared minus 2 squared minus, that should be a square there, okay, minus 4ac. So minus 4 times 1/3 times 4, which is minus 16/3. Okay, so this would give us, let me just do the math there. So minus 2 squared is 4, okay, minus 16/3, okay, which is a minus 4/3. Okay, so that's how we get that. Okay, so there is our discriminant. It's less than 0, so we can say the equation has no real solution. The nice thing about doing that discriminant first is, hey, if I'm trying to find solutions and I get a negative in the square root, I can stop. I can say, hey, you don't have any real solutions because your discriminant is negative. Okay, so let's look at some other types of equations. We'll start with an equation involving fractional expressions. Okay. Now, normally if we were just adding these two fractions, we'd have to find a common denominator, but because we have an equal sign, we don't need to do that. What we can do is just take the lowest common denominator and multiply it on both sides of the equation, and it eliminates those denominators. So it's a little bit easier actually with an equation because you don't have to get equivalent fractions. So for example here, our lowest common denominator is x times x plus 2. So if we multiply that x times x plus 2 on both sides of the equation, see here we have 2 on one side, and then here we have this thing on the other side. If we multiply that x times x plus 2 on both sides, what do we get? Well, we distribute it on here, we get 3 times x plus 2, and we distribute it on this one, and we just get 5 times x. So you see what happens is when you multiply this x times x plus 2 over here and over here, it eliminates that x and the x plus 2. So we just end up with this on the one side, and on this side we're going to distribute, so we get 2x squared plus 4x. Okay, so makes it much easier when we do that. Just multiply both sides by the LCD. In this case, it's x times x plus 2, and it eliminates those two fractions. Okay, so we're left with this quadratic. Now we simplify that. Okay, so when we simplify both sides, we get 8x plus 6 equals 2x squared plus 4x. We always want to get 0 on one side with a quadratic, so we're going to subtract 8x and 6 on both sides. Okay, and that gives us 0 equals 2x squared minus 4x minus 6 equals 0. Okay. Now, first thing we can do is divide both sides by 2, because these are all even numbers, these coefficients. So if we divide both sides by 2, we still get 0 over here. And then we have x squared minus 2x minus 3. Now this is one we can factor into x minus 3 times x plus 1. Okay, so that's actually easier to factor if you can factor it. So that gives us, using our zero product property, x minus 3 equals 0, or x plus 1 equals 0. So we get x equals 3, or we get x equals minus 1 as our solutions. And if we check our answers, for x equals 3, we get 2 on one side and 2 on the other side. So the left-hand side equals the right-hand side. And then for minus 1, same deal. We're plugging into the original equation, 3 over x plus 5 over x plus 2. So we plug in minus 1, we get minus 3 plus 5 equals 2, and that's the same as our right-hand side. So that works as well. Okay, we have a solution here with a square root. Okay, when you have that, you want to end up squaring both sides, but you always want to get that square root by itself. Okay, so we're going to move things around a little bit so that we have the square root by itself. Now it's okay that it has a negative in front of it, because remember, if you square a negative you get a positive, right? So it's okay that that's negative. So what we can do is simply just subtract 1 on both sides to get that square root by itself. We just don't want another number with it. We can have a negative in front. Okay. Now if we square both sides, we're going to get 2x minus 1 squared on one side, and the square of this is just 2 minus x. Okay. Think of this, if this were positive, it'd be the same thing, right, if you square it. So if you take the square of square root of 2 minus x, you get 2 minus x. If you take the square of minus square root of 2 minus x, you also get 2 minus x. Okay. Be careful here, though, because you have to FOIL this. Okay. You can't say 2x squared minus 1 squared. So we FOIL this. We get 4x squared minus 4x plus 1 equals 2 minus x. Okay, and then our next step is to get 0 on one side. So we're going to add minus 2 plus x to both sides, and that will give us 4x squared minus 3x minus 1 equals 0. Okay. Now this one we can factor. Okay. We can't do 2x and 2x, but we can do 4x and x. And if we do 1 and minus 1, we will actually be able to factor that. Think of 4x times x gives us 4x squared. 1 times minus 1 gives us minus 1. And then if we do the outside inside, we get minus 4x plus 1x equals minus 3x. So we can factor this. So we have 4x plus 1 equals 0, gives us x equals minus 1/4. Or x minus 1 equals 0 gives us x equals 1. Okay. Now we have to stress that these are potential solutions. Okay. Because we squared both sides, we can get answers that don't always work. Okay. So when we check our answers, we see that x equals minus 1/4 is a solution, but x minus 1 is not. Okay. So the only solution we really have is x equals minus 1/4. Okay. We call this solution where it's not working an extraneous solution, and that happened because we squared both sides. So you can square both sides to solve an equation, but you have to check your solutions to see if they work. So here's our original equation, 2x equals 1 minus the square root of 2 minus x. And we try x equals minus 1/4. We get 2 times minus 1/4, which is a minus 1/2. Okay. And then we take 1 minus the square root of 2 minus a minus 1/4. So 2 minus a minus 1/4 is 9/4, or 2 1/4. Right. And we take the square root of that, we get 3/2. So 1 minus 3/2 is minus 1/2. So that works. The left-hand side equals the right-hand side. So again, with our original equation, now we're going to try our other solution, x equals 1. Okay. So we have 2 times 1 equals 2, which is our left-hand side. But when we put in 1 on the right-hand side, we get 1 minus the square root of 2 minus 1, which is 1. This is square root of 1. 1 minus 1 is 0. So they're not equal to. So we can say x equals 1 is not a solution because it's not true here. And again, remember that happened because we squared both sides. So whenever you square both sides of an equation, you can get solutions that don't work, and you throw those out. We call those extraneous solutions. So it's very, very important that we check our answers. Okay, so we call these extraneous solutions, okay? Potential solutions that do not satisfy the original equation, okay? So for our previous example, x equals 1 is an extraneous solution, okay? So they may be introduced, they may come about when we square each side of an equation, okay? Because the operation of squaring can turn a false equation into a true one, okay? So here's an example. You know, this is not true, -1 equals 1, right? But if you square both sides, it is true, okay? So there's a simple example. You know, you can take two numbers that are not equal, but if you square both sides, they are. So that's how we can come about with solutions. Solutions like that can come about, extraneous solutions. Okay, so that's why you must always check your answers to make sure that each satisfies the original equation, because you can get those extraneous solutions, especially when you square both sides. Okay. The next thing we're going to look at is what we call quadratic type of equation. And that's where you have, now think of ax squared plus bx plus c equals 0. Now we have some algebraic expression where we have a times w squared plus bw plus c equals 0. So this thing is an expression and not necessarily just a variable, you know. But notice the form. We have real numbers a, b, c, but we have that thing, whatever it is, squared, and then here we have it just to the 1 power. Okay. So anytime you see this thing, whatever it is, it could be x plus 2, or it could be, you know, x to the x squared even, but you have it normal and then you have it squared. We call that quadratic type. Okay, and we can solve those just like a quadratic equation, except we have to do a substitution first. So here's one of quadratic type. Notice we don't have x squared and x, but we have x to the fourth and x squared. Okay. Now what we can do is make a substitution. Okay. We can say w. Sometimes I use u, but you can use w. If you let w equals x squared, you can see this becomes a w, and this x to the fourth becomes a w squared. Okay. So what we have is this form when we do our substitution. Okay. And you can recognize that by looking at your exponents and see how the exponent here is doubled here. Whenever you see the exponent doubled like that, and you only have these two terms with the variable in it, then you have a quadratic type. Okay. So when w equals x squared, I have w squared minus 8w plus 8 equals 0. Okay, so here's the quadratic we're trying to solve with w. W squared minus 8w plus 8 equals 0. I can't factor that, so I'm going to use my quadratic formula. My a is 1, my b is minus 8, and my c is 8. So I have w equals minus b, so minus and minus 8, plus or minus the square root of b squared, minus 8 squared, minus 4 times a times c. So minus 4 times 1 times 8 over 2 times a, or 2 times 1. This gives us a plus 8, and then this is 64 minus 32, which is, if we simplify that, it's 2 times the square root of 2. Okay, and then this would be 8 over 2 is 4, and then this would be 2 times the square root of 2, or 4 times the square root of 2 over 2. So we're just simplifying this, but this is what we get: 4 plus or minus 2 times the square root of 2. Okay, you know, I'll go over examples in class, but you know, I won't go through the details of how we got that. You should be able to figure that out. Okay, so this is our solution. W equals this, but we have to substitute back. So remember, w is x squared. So now we're going to say x squared is 4 plus or minus 2 times the square root of 2. Okay. Now, in order to solve this, we have to solve for x. So what we're going to do is we're going to take the square root of both sides here. Okay, to solve for x. And that's how we get x equals, now we have plus or minus square root of 4 plus or minus 2 times the square root of 2. So we actually get 4 solutions there. Okay, and let me write those out. Okay, so here's our 4 solutions, because we're doing plus or minus here and plus or minus here. So we'll start with pluses on the outside. So x equals plus 4 plus 2 times the square root of 2. X equals plus 4 minus 2 times the square root of 2. And then x equals minus square root of 4 plus 2 times the square root of 2. And then x equals minus square root of 4 minus 2 times the square root of 2. So we're doing combinations here, but notice we get 4 solutions when we do that. Okay, so for this one we have 4 solutions. So here are 4 solutions: plus plus, plus minus, minus minus, plus minus. And then if we use a calculator, this would be x would be 2.61, 1.08, minus 2.61, and minus 1.08. So here we actually have 4 solutions. So that's quadratic type. We'll look at some other examples of that in class on Monday.